Picture this. A team of scientists drills into Siberian permafrost, pulling out ice that hasn't seen the sun in tens of thousands of years. Inside that frozen tomb, they find something alive. Not mammoths, not plants, but viruses. Zombie viruses, as they've come to be known. Microbes frozen since the Ice Age, suddenly thawed and reawakened by rising global temperatures. Why this terrifies scientists? For most of history, we thought of ice as eternal, a freezer that keeps the past locked away. But as climate change melts glaciers and permafrost, it's not just methane or water that's being released. It's life forms, ancient bacteria and viruses, long gone from our world, suddenly set free. And unlike mammoths, viruses don't need to breathe. They don't need to move. They only need a host. The first proof. In 2014, French researchers revived a 30,000-year-old giant virus from Siberian permafrost. It was still infectious, though thankfully only to amoebas, not humans. But that was just the beginning. In 2023, scientists revived more, some frozen for nearly 48,500 years, and they remained capable of infection. If viruses that old can still wake up, the question becomes chilling. What else lies hidden in the ice? The bigger picture. Earth's frozen layers are not barren. They're a library of ancient ecosystems. Microbes, fungi, spores, and viruses from ages when humans didn't exist. As glaciers melt, these organisms aren't just thawing. They're re-entering ecosystems that have no immunity to them. And here's the key. Our world has changed, but microbes adapt fast. Some could mutate, cross over, and spark outbreaks no one alive has ever seen. So when we speak of climate change, we often think of heat waves, rising seas, or storms. But hidden beneath the thaw may be an apocalypse far smaller and far deadlier. In Chapter 2, we'll go deeper how scientists revive them, what makes them survive for thousands of years, and whether such ancient pathogens could ever infect us. Now you may be wondering, how can something so tiny, so fragile as a virus, survive tens of thousands of years frozen in ice? Let's break it down piece by piece. 1. What is a zombie virus? The term zombie virus is catchy, but in scientific terms, it simply means an ancient virus revived from permafrost or glaciers. These are not zombies in the horror movie sense. They are viruses whose ability to infect has been paused by freezing and then resumed when thawed. Viruses are essentially packets of genetic material, DNA or RNA, wrapped in a protein shell. If that shell is preserved, protected from heat, radiation, or decay, a virus can remain dormant for extraordinary timescales. 2. The perfect freezer. Why permafrost? Because it's nature's deep freezer. Low temperatures, constant sub-zero conditions halt biological decay. Low oxygen prevents oxidation, which normally breaks down organic molecules. Stable environment, shielded underground, away from UV radiation and weather cycles. In this environment, mammoths, woolly rhinos, plants, and yes, microbes have been found astonishingly well preserved. If mammoth flesh can stay intact for 40,000 years, so can viral capsids. 3. Proof of survival. Let's look at the hard evidence. 2014, France, researchers revived Pithivirus Sibericum, a 30,000-year-old virus still infectious to amoebas. 2015, Mollyvirus Sibericum, another giant virus revived from the same Siberian permafrost. 2023, Arctic study, 11 new strains of viruses, some nearly 48,500 years old, were thawed and shown to infect their hosts. And these weren't weak traces of viruses. They were fully functional. For could they infect humans? Here's the key question. So far, revived viruses have been chosen carefully for safety. They infect amoebas, not people. But scientists warn, there is no guarantee that all ancient viruses are harmless. Permafrost once locked away pathogens like smallpox, anthrax, and influenza. In fact, in 2016, Melting Siberian permafrost released anthrax spores, infecting reindeer and humans, killing one child and sickening dozens. That wasn't a virus from the Ice Age. That was a 20th century outbreak frozen in place. But it shows the principle: pathogens can endure in ice and come back. 5. The risk factors. The danger of zombie viruses depends on several factors. Viability. Not all viruses survive long-term freezing, but some clearly do. Host availability. An ancient virus may not find a modern host, unless it's a generalist capable of infecting multiple species. Mutation potential. Once thawed, viruses can adapt quickly. RNA viruses, like influenza, mutate at lightning speed. Scientists don't say we'll definitely face an Ice Age virus pandemic, but they agree the risk is real enough to study seriously. So, the science is clear. Viruses can survive in frozen time capsules, and climate change is cracking those capsules open, one glacier at a time. In Chapter 3, Climate Change, The Great Unlocking, we'll look at how global warming is accelerating the melting of permafrost, what's already being released, and why this may be one of the most overlooked consequences of climate change. When we think about climate change, we usually picture heat waves, wildfires, and rising seas. But there's a hidden consequence scientists are now sounding the alarm about. As Earth warms, its frozen past is waking up. 1. The melting permafrost. Permafrost, soil that has stayed frozen for thousands of years, covers nearly 24% of the northern hemisphere's landmass. It stretches across Siberia, Alaska, Canada, and Greenland. But rising global temperatures are thawing it at alarming rates. In some Arctic regions, permafrost that was stable for millennia is now melting decades ahead of predictions. And this isn't just mud and ice. Permafrost is a frozen archive, storing ancient plant matter, animal remains like mammoths, microbes, bacteria, and viruses. As it thaws, all of it is being released back into the world. 2. Real-world case. Anthrax outbreak of 2016. In Siberia, the summer of 2016 brought a heat wave that melted unusually deep layers of permafrost. Buried in those layers were the carcasses of reindeer infected with anthrax decades earlier. When the ice thawed, the spores reactivated. Result: over 2,000 reindeer died, dozens of people were hospitalized, and a 12-year-old boy lost his life. That outbreak was small compared to COVID, but it was a proof of concept. Climate change can resurrect pathogens we thought were gone. 3. Methane and microbes. It's not just viruses. Permafrost holds vast amounts of methane-producing microbes. When they thaw, they wake up and start emitting greenhouse gases, methane and CO2, accelerating warming in a feedback loop. In other words, the more permafrost melts, the faster the planet warms, the faster more permafrost melts. And within that cycle, pathogens could ride along unnoticed. 4. Future risk zones. Scientists have identified hotspots of concern where melting permafrost overlaps with ancient burial grounds and settlements. Northern Siberia, Alaska's tundra, the Canadian Arctic. These aren't just geological sites. They're potential sources of ancient disease outbreaks. Imagine influenza strains from centuries ago, or viruses that predate human immunity entirely. 5. Why this matters globally. Some may think, so what? These are remote places. But here's the reality. Air travel connects the Arctic to the world in hours. Migrating animals can carry microbes across continents. Thawing rivers drain into oceans, dispersing microbes globally. In an interconnected world, a thawed pathogen is never just a local problem. So climate change isn't just a story of rising seas or extreme heat. It's also the story of an ancient biological vault cracking open. And what comes out may not be fossils or mammoths, but killers too small to see. Next, in Chapter 4, The Pandemic Potential, we'll explore the nightmare scenario. Could a thawed virus spark the next global pandemic? And how does this compare to the risks we've already faced in modern times? We've seen that ancient viruses can survive tens of thousands of years. We've seen that melting permafrost can release them. But here's the big question. Could one of these zombie viruses spark the next pandemic? 1. Immunity gaps. One of the most frightening aspects of thawed viruses is that humans may have zero immunity. Think of it this way. Our immune systems are trained by history, generations exposed to certain microbes. We carry memory cells that remember smallpox, influenza strains, coronaviruses. But a virus that disappeared 30,000 or 50,000 years ago, no human alive, no immune system has ever encountered it. We'd be fighting blind. 2. Lessons from COVID-19. The COVID-19 pandemic was caused by a novel coronavirus, something new to our immune systems. In just 3 years, it killed more than 7 million people globally, officially, likely many more. Now imagine a virus far stranger, far older, one designed by evolution in an ecosystem long extinct. A virus our immune defenses have never seen before. If a single spillover event can cause global chaos, how much more unpredictable would a thawed, ancient virus be? 3. How a zombie virus pandemic could start. Scientists outlined 3 plausible pathways. 1. Local outbreaks in Arctic communities. Hunters, herders, or researchers exposed to thawed viruses in soil or animal remains. Just like the 2016 Siberian anthrax outbreak. 2. Animal carriers. Migrating animals like birds, rodents, or reindeer could spread a thawed virus into human contact zones. 3. Global spread via travel. In our hyper-connected world, an infected person from a remote Arctic community could be on a plane to a major city within hours. That's how a local outbreak could become a global crisis.
How real is the risk? Let's be clear. Scientists don't believe we're on the brink of an Ice Age virus pandemic tomorrow. Many ancient viruses may not even be capable of infecting modern humans. Others may be too fragile to spread efficiently. But the risk isn't zero, and as climate change accelerates, the probability grows. As virologist Jean-Michel Claverie, who led many of the revival studies, put it, the risk is real, and it is increasing as permafrost thaws. 5. Why preparedness matters. Here's the irony. COVID-19 showed us both the dangers of pandemics and the power of science. Vaccines were developed at record speed. Surveillance networks improved. But most of these systems are built for known pathogens. Would they detect something entirely alien? Something frozen since the Ice Age? That's the gap scientists warn about. So the question isn't just, could zombie viruses spark the next pandemic? The real question is, will we be ready if they do? It would be one thing if zombie viruses were only being released by natural climate change, but the truth is, humans are speeding up the danger. Through industry, greed, and curiosity, we are poking holes in Earth's frozen vault. 1. Industrial exploration in the Arctic. As ice retreats, industries see opportunity. Oil and gas drilling. Companies are expanding into thawing regions of Siberia, Alaska, and Canada. Each drill site digs into layers of once untouched permafrost. Mining. Rare earth elements, gold and diamonds lie beneath frozen soils. Mining blasts expose ancient soils that haven't been disturbed for millennia. Infrastructure. New pipelines, roads, and railways are cutting across tundra landscapes. Every one of these activities is like a crowbar, prying open layers of biological history best left sealed. 2. Tourism and human contact. The Arctic is no longer inaccessible. Cruise ships take tourists through thawing ice channels. Adventure travel brings hiker and filmmakers into fragile permafrost zones. Indigenous communities already living close to these ecosystems face exposure as well. With more human contact comes more risk of microbe transfer. What once stayed frozen in silence can now reach the global bloodstream. 3. Agriculture and resettlement. As the permafrost melts, new land becomes available. Some governments are eyeing this for farming projects, new settlements. But disturbing these soils could reawaken ancient pathogens buried right where crops or livestock are placed. It's the equivalent of planting farms in a graveyard of forgotten microbes. 4. The Pandora's box effect. Here's the unsettling part. Unlike a nuclear accident or chemical spill, we may not notice when an ancient virus is released. It could begin with one farmer's livestock falling sick, one villager with a mysterious fever. By the time doctors realize it's not a known disease, the pathogen could already be on a plane, spreading worldwide. COVID-19, which came from a living ecosystem, these viruses may come from an ecosystem humanity has no history with, which means our defenses, natural or medical, are even weaker. 5. Why this is a human problem. So yes, climate change is melting the ice, but our industries, our hunger for resources, and our reckless expansion are accelerating the release. We are not just innocent bystanders. We are active participants in unlocking Pandora's box, which leads us to the most haunting question. If we can't even control ourselves, how can we hope to control what's coming out of the ice? Next, in Chapter 6, Lessons for the Future, we'll explore what these zombie viruses teach us about preparedness, the systems we must build, the mistakes of past pandemics we must avoid, and the urgent decisions humanity faces now. We've journeyed through the icy tombs of our planet's past. We've seen that ancient viruses can survive, thaw, and even revive. And we've seen how human activity and climate change together are unlocking them faster than ever. But here's the truth. This isn't just a story of doom. It's also a story of preparation, foresight, and the chance to learn from history before it repeats itself. 1. Lessons from past pandemics. Every pandemic in history has left scars, but also lessons. The Black Death, 14th century, taught us about quarantines and the spread of disease across trade routes. The 1918 flu showed the importance of transparency. Governments that hid outbreaks suffered worse. HIV/AIDS reminded us that stigma and denial can kill faster than the virus itself. COVID-19 proved that global connectivity is both a strength and a weakness. Vaccines were developed in record time, but misinformation spread just as fast. Zombie viruses would test us on all these fronts. 2. Scientific readiness. What's needed now is proactive science. Arctic surveillance, monitoring permafrost thaw zones for microbial activity. Genome libraries, sequencing and cataloging ancient microbes to understand potential risks before they emerge. Safe revival protocols, strict guidelines for any lab handling ancient samples. Scientists like Jean-Michel Claverie argue that funding must expand beyond known threats into the realm of the unknown, because the unknown is coming. 3. Global cooperation. No single country can prepare for this alone. Why? Because microbes don't respect borders. We need international agreements for biosecurity in thawing regions, shared data platforms where discoveries are openly shared, not hoarded, joint rapid response units trained to contain outbreaks in remote Arctic areas before they spread. If COVID showed us anything, it's that fragmented responses cost lives. 4. Public awareness. Preparedness isn't only about scientists. It's about people. If the public dismisses zombie viruses as clickbait horror, then the political will to fund defenses vanishes. But if people understand the risk, calmly, scientifically, then awareness becomes its own form of defense. As Carl Sagan once said, extinction is the rule, survival is the exception. Awareness, vigilance, and preparedness are what keep us in that rare exception. 5. The ethical question. And finally, we must ask, should we even revive these viruses in labs? Some argue it's too risky. Others say it's the only way to study and prepare for them. This debate is ongoing, but one thing is certain: we cannot afford ignorance. The lesson for the future is simple, yet profound. The ice is melting. The past is awakening. Whether we face disaster or resilience depends on what we do today. And that brings us to Chapter 7, Final Reflection, where we'll close with a challenge to humanity. Will we prepare for the return of ancient life, or let the past writ? We began this journey drilling into the ice, and what we found was not silence, but whispers from the past. Viruses frozen for tens of thousands of years, locked away until climate change and human greed began cracking open the vault. 1. The reality we must face. The truth is simple. Ancient pathogens are not myth. They exist. They've been revived in labs, and at least once already, they've spilled into the modern world. In the anthrax outbreak of Siberia. This is not a horror story. This is a warning. 2. The choice before us. We stand at a crossroads. We can ignore the threat, laugh it off as science fiction until the day it isn't. Or we can prepare by funding science, monitoring the permafrost, building global cooperation, and treating biology with the respect it deserves. Because the real apocalypse isn't an ancient virus itself. It's our failure to take the possibility seriously. 3. A message to humanity. So here's the question I leave with you. Will we let ice age write our future? Or will we write it ourselves with awareness, resilience, and responsibility? The choice, as always, is ours. 4. Call to action. If this video opened your eyes, don't let it stop here. Watch the Grey Goose scenario, how runaway nanobots could consume the world. Then binge the Apocalypse playlist, where we explore the universe's most terrifying endgames, from vacuum decay to cosmic collapse. Because these aren't just stories. They're warnings, and knowledge is the first line of defense. So hit like, share this video, and subscribe. Not just for the algorithm, but because awareness can save lives. The ice is melting. The past is awakening. But the future is still in our hands.